Today we are going to solve the problem 5.1 of Griffith 4th edition, Introduction to Electrodynamics. The problem 5.1 is a particle of charge Q enters a region of uniform magnetic field P, uh, pointing into the page. That is very important. The field deflects the particles a distance t above the original line of flight. That is, this is the original line. It is uh, uh, moving at distance t from the original line. So, as shown in this figure, is the charge positive or negative? In terms of A, D, P and Q, find the momentum of the particle. First, I will explain this diagram. Before that, we have to find the whether the a particle is having positive charge or negative charge. So, sign of the charge. We know the force is equal to magnetic force is equal to Q into V, velocity multiplied by P. That is, this is cross product, vector product. So, the particle is moving along a positive x direction. So, we can write this as plus x cat. That is, x is a unit vector. So, particle is moving along x direction. And the magnetic field is inverts the space. That means it's a negative z axis. So z cat, unit vector along z direction. This is negative. Remember that if product x plus x cross y is equal to z. Similarly, z cross x cyclic. If it is z cross x is plus, but it is x cross z. Naturally, one negative factor will come. Already there is one negative here, so this will become positive. So uh, x cat cross minus z cat is equal to plus y cat. That is, a particle moves upward. So the particle is deflected upwards, hence it is positive. So no doubt the particle is having the positive charge. This is the field region. Particle comes here. So this here A is the horizontal distance. This is horizontal distance along x-axis, and T is the displacement. This is distance from the where the particle enters and the where the particle leaves. So the particle enters here and particle leaves here. You can draw a parallel line similarly here also at the distance d. So this is a distance t. So at the origin, particle enters into the field and it leaves the field at this distance t. This is the t is the displacement. Now we have found that the particle is having a positive charge. Then we will move on to next question. That is, we have to find the momentum of the particle in terms of a. That is uh, horizontal distance, and d displacement. P is the magnetic field and q is the charge. We know very well that the magnetic field deflects the charged particle. So it take a circular path. So this magnetic force is equal to the centripetal force. So modulus F is equal to QVP, uh, where V is the velocity, Q is the charge, P is the magnetic field, which is equal to the centripetal force mv squared over r. Here we can cancel v and with this v squared, which will become v. This mv is equal to momentum p. So this q multiplied by p is equal to p over r. Here r is the radius of curvature. You know very well. Radius of curvature. If radius of curvature is small, that means magnetic field is high. So high magnetic field deflect faster the uh, charged particle. So now you bring R to the other side. So P is equal to Q multiplied by the magnetic field multiplied by the radius of curvature. Now we know the charge of the particle and magnetic field, what we are applying here. Only unknown parameter is radius. We will calculate the radius using, I will explain this how to calculate using a very simple diagram. Now our task is we have to calculate the radius of curvature. I have drawn the equivalent diagram here. See here, this point we are sending the particle charge q at velocity v. So this is A. Sorry, 1 minute. This distance between where particle enter and where particle leaves is A. I am drawing a parallel line here, which is actually this is also A, and this distance is D. This distance. For explanatory purpose, I have redrawn this diagram. So you can understand this having a radius of curvature. Uh, that point R is origin. This point is R, so here also this blue color one also R. This yellow color dotted line also R because it's a radius. Radius will be same. So now we have to find the radius R. So we know this distance is A because it's a parallel line. And what about this distance is D. Distance between this point and this point is D. So now what you can write, you need this distance. This distance naturally r minus t, r minus t. So naturally what is r squared? Pythagoras theorem, r squared is equal to r minus t whole squared plus a squared. Here this is a. This is equal to this squared, that is r minus t squared plus a squared, this one, plus a squared. Now you expand this out, which is equal to r minus t whole squared is equal to r squared plus t squared minus 2rt plus this a squared. Now you bring this r to the other side. So r squared minus r squared is 0. Here you have minus 2rt plus t squared plus a squared. Now this can be written as 2rt, which is equal to t squared plus a squared. So r can be written as, you bring this 2t to other side, a squared plus t squared over 2d. So now we know the distance a, horizontal distance is measurable, we can measure, and t also we know. So from this a and t we can calculate radius using this formula. Already we have seen the momentum is equal to q into p into r. I am replacing r by this. So P is equal to Q P A squared plus T squared over 2D. Here all are measurable quantities, so we can easily find out the momentum of the particle. If you find this problem useful, kindly like it and subscribe it in order to get my updated lecture. Also join to my channel for the growth of my channel. Thank you very much.